Hey guys, today we're going to talk about polynomial equations. So we're going to apply the factor and rational root theorems that we learned previously to find roots of polynomial equations. And we're also going to solve polynomial equations. So let's review that factor theorem that we learned a really long time ago. It says that if P of R is equal to 0, so some x, that makes y equals 0, where r is a real number, then x minus r is a factor of p of x. Okay, we also have the complete linear factorization theorem, and that says that every polynomial of a degree n factors completely into the n number of linear factors. So a polynomial of equation of degree n has exactly n roots. The thing is with those roots though, even though it has the n number of roots, some of them may be repeated roots or some of them might be complex roots. So let's look at an example. We're going to use synthetic division and we're going to determine which of the numbers between -2, -1, 1, and 2 are roots for the equation 3x cubed minus 8x squared plus 5x minus 2 equals 0. So let's set it up. So synthetic division looks like we're going to test the number 1 first. And remember, you use the coefficients. So the coefficients for x cubed is 3. The coefficient for x squared is -8. The coefficient for x is 5. And then our constant is -2. So remember, we bring down the first number and we multiply. 1 times 3 is 3. And then -8 plus 3 becomes -5. Next thing we do is multiply 1 times -5. That gives us -5. 5 minus 5 is 0. So now we multiply 1 times 0. 1 times 0 is 0. -2 plus 0, that's -2. So we got a remainder here, which means that 1 is not going to be a root of the equation. Let's try -1. So set it up. We're going to bring down the 3. -1 times 3 is -3. -8 minus 3, -11. -1 times -11, positive 11. 5 plus 11 is 16. And then -1 times 16 is -16. -2 minus 16, ooh, that gives us -18. Which -18 is a remainder, which means that -1 is not going to be a root. Now let's look at, repeated that. Okay, let's look at -2. So bring down the 3. -2 times 3, -6, -8 minus 6, -14, -2 times -14, 28, 25 plus 28 is 33, -2 times 33, -66, remainder, which means that -2 is not a root. So the only members of this set that is a root of the equation is 2. 2 is the only root, which means that P of 2 is equal to 0. If you plug 2 in, you get 0. The factor theorem guarantees that x minus 2 is a factor. So notice the difference between a root and a factor. The root is 2, which is what we divided using synthetic division, but the factor is x minus 2, because remember, we're factoring. Okay. So let's go ahead and practice. Go ahead and pause the video. Try this problem on your own and see if you can't get a correct answer. Welcome back. So I'm going to go ahead and start off with my lucky number 2. Bring down my 3. 2 times 3 is 6. 2 plus 6 is 8. 2 times 8 is 16. -19 plus 16 is -3. 2 times -3 is -6. Get a 0 remainder. Yay, lucky number 2. So just so you know, I chose 2 because I knew 2 was the answer. But you might have to go through every single number before you find a number that works. And that's okay. Sometimes that's going to happen. But we do know that 2 is a root. All right, so next example, we have x cubed plus 4x squared minus 2x minus 8 equals 0. And they tell us, well, x plus 4 is a factor of the polynomial. So if we know that x plus 4 is a factor, why don't you go ahead and solve that polynomial? Oh dear. Okay. Well, x plus 4 is a factor. That means negative 4 is a root. So we're going to go ahead and use synthetic division to see what our other factor is. Okay. So bring down the 1. Negative 4 times 1 is negative 4. 4 minus 4 is 0. Negative 4 times 0 is 0. Negative 2 plus 0 is negative 2. Negative 4 times negative 2 is positive 8. And we get 0 remainder, which is good because we said that negative 4 was a root. So it should equal 0. If it's not equal to 0, then check your synthetic division because it's given that x plus 4 is a factor, which means that it's given that negative 4 is a root. All right, so because of that, remember when we're using synthetic division, we are taking down a power. So since our power started at x cubed here, this 1 is actually 1x squared. So we have 1x squared plus 0x minus 2. So when we factor it, our first factor is the x plus 4 that was given to us. And the second factor we got from synthetic division. Here is the 1x squared, the 1x squared. Notice that 0x is not written into our factor because 0x is just 0. But then we do have the minus 2 constant, which we got from our synthetic division. All right, so now that we have our polynomial completely factored, so in order to solve, we are going to set both of the factors equal to 0. So x plus 4 equals 0, or x squared minus 2 is equal to 0. Okay, so let's go ahead and solve for x. So on one case, x is equal to negative 4, which we knew because it's a root, but our other roots are plus or minus the square root of 2, which means we have 3 roots. One root is negative 4, one is the square root of 2, and the other one is negative square root of 2, which makes sense because our degree is 3, which means there should be 3 roots. We are going to try 3 first. We're going to see if 3 works. So remember, we got 3 from doing C over D, and 3 was one of the possible roots. So we're going to see if 3 is a root or is not a root. So we're going to use synthetic division. And when we use synthetic division, oh, it works, yay! So we got lucky number 3. Now again, depending on the method that the order in which you're trying, you might go through several numbers before you discover that 3 is a possible root. Once you know that 3 is a possible root, you can try another number. Like say, for example, negative 6. Oh, negative 6 works. So that tells us that x minus 3 is a root, and then x plus 6 is a root, and x squared minus 3 is a root. And you're like, where did this x squared minus 3 come from? Well, when we were doing synthetic division and we tried 3 and 3 worked, that left us with x cubed plus 6x squared minus 3x minus 18. So what we did is we took that polynomial and tried another number. And we have negative 6 here because it worked out easy, but you actually might have to try several numbers before you get to negative 6. And then once negative 6 worked, that got us our x plus 6, leaving us, since this was x cubed, here it went down to x squared plus 0x minus 3. So that's how we got x squared minus 3. So basically, I skipped a step. Basically, this was our x fourth plus 3x cubed minus 21x squared minus 9x plus 54. And once we were able to find 3 as a factor, that left us x cubed plus 6x squared minus 3x minus 18. And so I could have written that out. I could have written out x cubed plus 3x squared minus 3x minus 18. But instead of doing that, I decided to go ahead and skip a step and go ahead and keep trying again until I was able to get another factor. So that's how I got these three factors. Which means our roots become negative 6 from the x plus 6, 3 from the x minus 3, and then plus or minus the square root of 3 from the x squared minus 3. All right, so here's an example. 2x cubed plus 5x squared minus 2x minus 5. So first, we identify our c, which is the factors of our constant. Our constant is negative 5. So our factors are going to be 1 and 5, plus or minus. Our factors of our leading coefficient, which is d, leading coefficient is 2, so those factors would be 1 and 2, plus or minus. So our c over d is all possibilities. So first we look at our c, 1 and 5, and put it over 1, which means we get plus or minus 1, plus or minus 5. Then we take our c's, which is 1 and 5, and we put them over 2, our other possibility for d. So we end up with plus or minus 1/2 and plus or minus 5/2. All right, so we're going to test one of those out. We're going to test positive 1 first. So we're going to go ahead and set up a synthetic division problem, see if 1 will work. And it does, which tells us that 1 is a root, which means that x minus 1 is a factor. And our other factor is going to be 2x squared plus 7x plus 5. And so since that is our other factor, since 2x squared plus 7x plus 5 is our other factor, in the previous example, we had to do synthetic division again, but I noticed that this is a quadratic, and so that way I can factor it because I know how to factor quadratics. So it becomes 2x plus 5 and x plus 1. So again, I just took this, which was my answer to my synthetic division problem, and I factored it again to make it linear. So I get 2x plus 5 and x plus 1. So now I have my three factors, which means that I have my three roots. I have x is equal to negative 5 over 2, which comes from this factor, 2x plus 5. I got x equals negative 1, which came from this factor, x plus 1. And then I have x equals 1, which came from the factor x minus 1. All right, so we are done. That's it. Okay, but before we go, I want to read a quote to you. So checkers or chess help to develop and improve our powers of thought and calculation and judgment. Sometimes, when I am weary with my work, I take down my Euclid and go over a few propositions, or I work out some of Bland's equations, just by way of amusement. That kind of exercise is as much a recreation to me as running out in the fields would be to a boy at school. Charles Haddon Spurgeon said that, okay? And he lived from 1834 to 1892. So who is this guy? Well, Spurgeon is a famous London preacher. If you Google Spurgeon's quotes, you're going to come up with a lot of really neat sayings and quotes that he said. And so he had said something about taking down his Euclid. So what's Euclid? Well, Euclid, it was a famous mathematician, Euclidean geometry. He specialized in geometry, and so Euclid would be a book about proofs, and that's what propositions are. They're mathematical proofs. And when he's talking about he works out some of Bland's equations, he's talking about quadratic and polynomial equations. That's what you're working on. So Bland's equations, he would do them for quadratic equations. He would do them as recreation. The term Bland's equation is actually from a book, Algebraical Problems Producing Simple and Quadratic Equations and Their Solution, by a guy named Miles Bland. So that's why he calls them Bland's equations, because he's the guy who wrote that book. So we want to know, what is this old preacher guy talking about? Well, he wants to stress that why we do math. Okay, why are we doing pre-cal? We're never going to see this again. Well, the reason why is because we're developing our minds as preparation for Christian service. Such preparation requires the study of theology and ancient languages, depending on what field you're going into. So theology involves logical deductions from axioms of Scripture, and mathematics is all about that. The reason we do the way that we do, the reason that addition works the way it does, is because of a logical deduction based from axioms of mathematical statements. Okay? So while ancient language requires attention to details of letters, accents, grammar, and syntax. So this is technical detail that is so important in math. Like this, the mathematical training you get is to pay attention, watch your steps, check your work, make sure you're doing correctly. So you're preparing yourself for other things when you do that. You're preparing your mind and a mindset to do that. Well, that's all I have to talk to you about today. I hope you enjoy your video. Again, I'm going to be looking at your notes and seeing how much notes you wrote to determine your homework grade. So take care.